Alright, welcome back guys. In this video here, we're going to be talking about how to solve absolute value equation and inequalities. Just quickly, we can review the definition of absolute value. Okay, so we say that the absolute, can't spell this right now, absolute value of a number is the distance from 0 to that number. Okay, and the notation we use is the 2 vertical slash. Okay, so for example, if we're saying that, okay, well, I want to figure out the distance from 0 to phi. Okay, so the absolute value of phi is going to be phi, because if you're looking at phi from 0, 4 phi, right? So if you're looking at the position phi, that is phi units from 0, right? So that is phi. So the absolute value of phi is going to be phi. So if we ask to find what is the absolute value of negative phi, well, if you look at negative phi, 3, 4, 5, that's negative phi. And we count how many units from 0 to that number. Well, this is 1, 2, 3, 4, 5. So the absolute value of negative phi is still phi, because it's referring to distance, and distance is always positive. So we say always positive, or it can't be negative. Okay, so the absolute value of any number is going to be always positive. Okay, so now we can try to solve some equations. So the first example, let's try solving the first example. Okay, the first example say that let's find the solution set to these problems. Okay, so A is asking for, okay, what is x such that the absolute value is equal to 3? So this question is asking, okay, what value or values of x so that the distance from 0 to x is 3 units. Okay, so that's the questions. That's the equation interpreted by just describe what the equation means. So if you look at this in terms of the number line, if I draw a number line and I say, okay, well, here's 0. Okay, well, how do I get the distance from 0 to be 3 units? I can either go 3 units to the positive direction or 3 units to the negative direction. So the two possible values that have exactly 3 units away from 0 will be 3 and negative 3. Okay, so that's that's how we can look at this as through number line. But usually when we solve something like this here, we want to follow some sort of rule, so that way remember, meaning we don't have to draw the number line every single time. What if the equation get a little more complicated, right? So if we have an absolute value equation, then the x value can be the positive of that to get distance in 3 units, or the x value can be a negative of that number to get the same 3 units distance. Okay. Part B is asking for what value of x so that it is 0 unit away from 0. Well, if you think about it, there's only one number that is 0 unit, 0 distance away from 0. Okay, so that number is 0 itself. Okay. C, what value of x so that it has a negative 3 units from 0. Okay, we talk about that distance can't be negative. Okay, so in this case, there is no such x value that has a negative distance. So we say that no solution. There is, or we can say absolute value based on definition of a number can't be negative. Okay. So now, if we're trying to solve little more complicated equation than the one we just did. Let's look at example 2. Okay. So example 2 says solve each absolute value equation. So this is a little hard to draw a picture. Just saying that what value of x such that 3 times that number, x, subtracted by 2, and the distance of that add 3 is equal to 10. All right, so there's a lot to be able to portray that geometrically or in terms of picture there. But what we can do is we can try to get this absolute value equation simplify, meaning we can try to get the equivalent form of this as simplified as possible, so that way we can solve for what x has to be. So we use what we know already is just solving equations. So first we subtract the 3. Okay, so that will give us absolute value of 3x minus 2 equal to 7. So this is a little bit easier to interpret than the one we had before. They're saying that what value of x such that 3 times that number minus 2 its distance is 7 units away from 0. Okay. So still not easy to kind of imagine the picture in your head here. But what we can say is that, okay, whatever x has to be, whatever x going to be, okay, when we times that by 3 and subtract 2, this result here, okay, that result there can be a positive number or negative number. If it's a positive number and we take the absolute value of that, it gives us 7, then it's going to be positive 7. If 3x minus 2 is going to be a negative number, and then when we take the absolute value, it's going to be positive 7 still. So this gives us two possibilities. We can say whatever x is, 3x minus 2, that itself can be turned out to be negative 7 to make this work. Make that positive first. Positive 7, that's one scenario. Or the 3x minus 2 is going to be negative 7. There's only two possibilities. Okay. All right, from there, we can solve for x for each equation. So x is 3, or x is negative 5/3. Okay. All right, so let's just kind of try this out, just one of this answer here. All right, so let's just look at this. Okay, here's 0. So when x is 3, 1, 2, 3. Okay, so if 3 times 3, so 3 times 3 is 9. Okay, so 1, 2, 3, 4, 5, 6. So that's 9. So we go from here to 9 if by times 3. And then we're going to subtract that by 2. So we're back to 7. Okay, so 7. Okay, absolute value of 7 is going to be 7. Plus 3 is going to be 10. So it's going to be 10 over there. Okay, so that's 10. So that is 10 distance away. So it's checked out. So these are the correct answers here. Let's try part B. Okay. Part B is asking for what is x such that 3 times x, absolute value of that, subtract 5 equal to negative 5. Now if you look at this here and trying to isolate the absolute value by itself, adding 5 to the other side will give us 0. And then we mentioned that earlier already. Well, the absolute value of any number, negative 3 times x, or anything inside the absolute value, to get 0, x must equal 0. Because if you use any number in here, you're going to result in an absolute value greater than 0. But we want that to be equal to 0, so x has to equal 0 in this case. Okay. You may see some example where the equation involve double absolute value notation. Okay. Well, this look complicated, but it's not really anything different we just learned. Okay. So if you have the absolute value of x minus 3 equal to x plus 5 absolute value, so we can have this scenario here. We can say that whatever x has to be, okay, by plugging x into both sides, suppose whatever that x we're trying to find, this left side here can be, this x minus 3 can turn out to be positive, this thing inside, or negative. And then over here, the 2x plus 5 can turn out to be a positive number or negative number, okay? So we have either, either this positive and positive, or positive or negative scenario, okay? So either have left side being positive and right side being positive, or left side being positive and right side being negative, okay? Or if we go the other way, if we look at the right side can be positive, and then the left side can be positive. And then, oh no, let's go to negative, sorry. So now, if we say, okay, now let's look at the negative side. If we say the left side value can be negative, it can be positive there and negative there. So we say negative on the left, positive on the right, negative on the left, and then negative on the right, okay? So it turns out that this scenario is the same thing as this scenario, okay? If you divide both sides by negative ones, it's going to be plus plus. And this scenario is going to be the same thing as that scenario. So really, we just have two possible cases here. So not much different from what we just did in the previous example. Okay. So going back to this problem, we can break this down and say, okay, well, I can either have both sides of this absolute value equation, double absolute value equation, to have the inside of that being the same sign. So being the same sign meaning positive. Or we can say one of these two is going to be negative. Okay, so if I choose the right side to be negative, I need to show that. Okay. All right. So these four cases here broken down to the two cases down here. Okay. So it's always going to be, the things inside the absolute value being the same signs or opposite sign. Okay. All right. So solving the first equation, we get negative x equal to 8. Bring the 3 on the other side, subtract 2x to the other side. So therefore x equals to negative 8. Solving this side, we get x minus 3 minus 2x minus 5. That means 3x equal to negative 2. That means x equal to negative 2/3. Okay, so those are the solutions. And you should always check your solution to be sure that it's true. Let's do one with inequalities. Okay, inequalities is slightly more confusing. Okay, but before we do this example, I want to just look at some picture real quick and kind of show you guys where we're heading here. So absolute value inequalities. Okay. All right. So if I want to look at all the numbers x such that is less than 3, okay, in terms of picture, this one's saying that all the number of x that has a distance from 0 to that number is less than 3 units is either all these numbers here, okay, here's 3, so all this number will satisfy that, or if we talk about distance, we can go to the left direction, all this number here as well, right? But we can't have 3 and negative 3 being part of that answer because we want that to be strictly less than 3. So here's where x lies, either there or there, okay? So that inequality becomes this double inequality. Okay, the solution set will be all the number of all the values, all the real number x has to be between negative 3 to 3. That will make certain that it has a distance from 0 to that number less than 3 units. So if I pick this number here, that distance is less than 3 units, right? And then from there, we can translate this to interval notation. Okay. So now, let's look at where the inequality is greater than. Okay. So if we have the absolute value of x greater than 3, well, this means I want to look at all the possible value of x so that the distance from 0 to x, let's say here's x. I want that distance there to be greater than 3 units. So 1, 2, 3, here's 3. So if x is picked on the right side of 3, it's going to yield a distance, right? Distance from 0 to x must be greater than 3. So all the x we're looking for S part solution has to be on the right side of 3, but we can also go on the negative direction. So if we look at negative 3 there, if we pick any numbers on this side here, it's going to guarantee that, you know, that has a distance greater than 3. So if here's x, then it's going to be greater than 3 there, okay? So we have to write this as two separate inequalities. All right, we can say that the first inequality, the value of x can be obtained by taking x and then making that greater than 3. That will guarantee the distance be greater than 3. Or if we pick all the x values to the left of negative 3. To the left of negative 3 meaning less than negative 3. Okay, so that would yield the solution there. Okay, so in terms of interval notation, we have this. We have excuse me. We have all the x from negative infinity to negative 3 union 3 to positive infinity. That will be the solution. Okay. So now when we apply that to this example here, you want to pay attention to the inequalities. Okay. And since the inequality is less than or equal to, it's very similar to this one that we did up here. Okay. And if the inequality is greater than, yeah, let's change that to be greater than 4. Let's change that to greater than 4. When you do this type of absolute value inequality, what you want to make sure is that you isolate the absolute value inequality by itself first. Okay, so now there's nothing in front or add to that. So we can go ahead and say, okay, well now this can be broken down to 2x minus 3. That value has to be between 7 and negative 7 to make sure that we have a distance less than or equal to 7. And over here, what you want to do first is you want to divide by the constant first. Isolate that absolute value first. So we get negative 2x plus 1, absolute value greater than 1. Okay. Then you apply what we did up here. If the inequality is greater than, right? If the inequality is greater than, right, then the two inequalities can be negative 2x plus 1 be to the right of 1, or negative 2x plus 1 be on the left side of negative 1. Okay, so if we find those x values for those two inequalities, those will be the solution for this inequality. Okay, so going back to this first one here, if I was to solve this, I can add 3 here, 3 there, 3 there. That gave me negative 4 less than 2x less than 10, and I can divide 2, divide 2, divide 2. That gave me negative 2 less than x less than 5. So my solution is going to be negative 2 to 5, parenthesis, interval notation from negative 2 to 5. Over here, if I was to solve these inequalities, I get negative 2x greater than 0. Therefore, x is less than 0, because when we divide by negative, the inequality change. And then over here, negative 2x less than negative 2, divide by negative 2. If we divide by negative 2, the inequality is going to change again. So greater than 1, because if we divide by negative 2, we get 1 out of that. So this is an OR statement, okay? Because when we look at the picture, it's either to the left of that number or to the right of that positive number, okay? So if I draw this in terms of the graph, our solution set looks like this. Here's 0. So we can have the solution set everything to the left of that. Okay. Or we can have the solution set to the right of 1. Okay. All right. So it's an OR statement. So we can say solution is negative infinity to 0 or union 1 to positive infinity. So the less than inequality here will yield an AND statement. So we said, less than imply AND statement, and then greater than will yield an OR statement.